turned it on and checked it all out, compare the radiation at the top of the atmosphere, which the balloon will do, and that's part of the radiation broader the aircraft from flying much lower in the atmosphere will compare the radiation at the top of the atmosphere, which the balloon will do, after all, Radix to the radiation to learn about how radiation is flying much lower in the atmosphere will experience. Pilots, flight crews, and passengers like us will fly is helping us to learn about how radiation
so you can't get away from that instrument because you were actually helping out the Radix team in the air today by turning on the instrument.
That's right.
Well, John, thank you so much for joining us today. So you can't get away from that instrument because you were actually helping out the Radix team in the air today by turning on the instrument.
That's right.
We're here
with John,
Ryan Norman, who's a member of the science team for Radix.
And we'll see you out for the launch.
I understand that what we're looking at for Radix, Ryan Norman, who's a member of the very high up team for Radix, and then looking at it as it changes as it moves through. So how is Radix sort of radiation at very high up in the atmosphere,
and
then looking at it as it changes as it moves through? So how is Radix going to help us do that?
So Radix is going to fly at 2 different altitudes. So we're going to start off at really high altitudes, and then we're going to valve down about 12 hours later to get a different altitude. And the point is that the radiation, as it interacts in the atmosphere, changes with altitude. And so the balloon is going to measure at 2 different altitudes to try to give us 2 different data points on the radiation levels, and so that we can help build our models better.
Okay, so I understand that there are other assets gathering data sort of at the same time. Does that mean that you have to fly those assets sort of in the same general vicinity as Radix?
We want to be in the same area and fairly close in time. The space radiation environment doesn't change much in time.
Sort of
day to day, it's pretty much the same. So as long as we fly in reasonable temporal vicinity, we'll be good. And we want to be in the reasonable geographic area also. So we want to fly close to where the balloon will be flying.
Once you fly Radix and you get the data from very high to the valve down area to the other assets, what are you going to do with that data? How do you use that to our benefit?
So we want to use this data to develop better models to help characterize the radiation environment in the atmosphere. We want to quantify the radiation received by airline crews, and we have a whole model called NERIS that's set up to do that in sort of real time. And it's built on this notion of terrestrial weather, where we're going to take data in real time from the space environment outside the Earth's atmosphere to hopefully data on airplanes in real time, ingest all that data and figure out what, say we're flying back to Albuquerque to launch Radix 2.
Yeah, right.
And,
good plan,
And we want to know what our radiation dose is on that flight. NERIS gives us that information. So it tells us the dose that, the air crew or the people on the plane might receive at any given moment.
Awesome. Well, I know you're going to get great data. Very excited about it. Thanks so much. And we look forward to good results from Radix.
We're very excited, and hopefully we get off the ground today.
Awesome. Well, we had a chance before we even went out to Fort Sumner to talk to some of the other team members from Radix. Let's check it out.
So Kevin, what's your role in Radix?
So my role on Radix is the project manager. As the project manager, I get to work on a day-to-day basis to keep an eye on our funding, keep an eye on our resources and our personnel, to make sure that everybody on the team has exactly what they need when they need it.
So what you're telling me is you're the top dog.
I am the top dog. I'm the head cheese. So on a day-to-day basis, it's great because as a training opportunity, I've gotten the ability to step up into this role when normally I wouldn't get such an opportunity. But to run the meetings, to lead the team, and get to have them report on up. But then also I do get to turn around and talk to our program office and talk to our other stakeholders to make sure that I keep them in the loop at the same time.
At this point, what's been the most rewarding part?
I've actually gotten to see a lot of growth out of some of the younger individuals who came on board. At the very beginning, with a new team put together, you just never know how things are really going to play out. But looking at the individuals as they've gotten to come along, it's kind of been nice to take some of my experiences, my past experiences, and pass those on to even some of them, even though I am myself a very early career individual. The most rewarding part of the payload coming together is seeing the hardware structure. The most rewarding part of the payload coming together that leads into doing the hardware mission simulations that we're working on this week. And then that leads into doing things like the mission simulations that we're working on
it's an all-day event. What does that entail?
So for a mission simulation, what we do is we get started at 7 in the morning where the team meets around the payload. We then talk about what we're going to do for the day. For example, during one of the the recent mission simulations, we took the payload do for the day outside. For example, during one pavilion where we simulated satellite, we took the payload. We used the satellites out to the pavilion where we bring the data down in real time so that we can monitor the health and status of the payload, communicate and bring the data down in real time so that we can monitor the health and status of the payload. Once the payload is outside, we get set up for the day. We talk a little bit more about what we're going to do. We make sure that everything is set up and running. We talk a little bit more about what we're going to do. We make sure that everything is set up and running. Or the science operations center. That is where the data comes down to. So when the data is collected on the payload, that is where the data comes down to. So when the data is collected on the payload, it is transmitted into our mission operations back down to Earth. The individuals in the mission operations center during our simulation are trying to watch the individuals in the mission operations center during the simulation. So are trying to watch. The team gets to spend some time during the watching the payload. So the team gets to spend some time day-to-day routines the payload that we'll use when we actually fly. Commands to the payload and practicing the day-to-day routines that we'll use when we actually fly.
So I'm the avionics lead, which means that I'm in charge of all the electronics on the project. So I'm the avionics lead, which means that I'm in charge of aviation electronics on the project. So any electronics avionics fly in the flight environment, aviation electronics. So in that role, any electronics that fly in the flight environment, making sure that all the science instruments interface appropriately with electronics, making sure that all the data that we need interface appropriately with the electronics that we're collecting on the data that we need, that we're getting all the health and status information that we need on the ground.
So it sounds like a pretty big role because
we have 4 different science instruments that are collecting data. But then to make sure that they're operating nominally, science instruments that are collecting data. But then to make sure that they're operating nominally, and various other measurements that we're making that we can be sure on the ground, and various other measurements that we're making so that we can be sure on the ground and the system is actually operating nominally.
Now, will you also be responsible for getting that data from the system once you recover
the way that we
and
have the
getting it
mission
to
set
the
up.
science leads?
Our onboard system is actually the way that we main way for recovering the data. So when we recover the payload system is actually depending on what main way for recovering the data. So when we recover the payload, I'll be involved depending on what state it's in. We get the data from paths we could take, but I'll be involved in making sure that we get the data off and get it to the science team.
Getting involved initially with Radex and up to this point now where you're ready for flight. Getting involved initially with Radex and up to this point now where you're ready for flight.
Especially
how's that
coming into NASA. It's been a great experience. So far, my NASA experience is very much been defined by this project. Fresh out. We've had so far my NASA experience is very really great leadership project, and we've had a great really good chance to get hands-on really great leadership working with other disciplines. I've had a really good chance to get hands-on experience working with other disciplines and NASA really taking responsibility. So I've grown a lot as an engineer and as a NASA employee as well.
So what's your role in Radex? So Denise,
sure,
we have a big launch coming up.
So
what's your role in Radex?
So part of my task is to ensure that all the components that have been individually designed come together, and we test them in similar environments, individually designed, come together, and we test them in similar environments, all of our electronics and all our data, and that gives us confidence going into the launch that all of our electronics and all our data is going to
kind of tell us a bit how you got involved with Hope part of this Hope program and your experiences so far. Kind of tell us a bit how you got involved with Hope
probably one of the most
and your
amazing
experiences
things
so far.
in my personal experience that the agency has done. Probably one of the most amazing things in my personal experience that the agency has done. 10 years maybe from concept to launch. Radex really was able to go from concept to launch in a very short period of time. Radex and what that does for us as engineers, young engineers, is give us visibility to the other disciplines. Young engineers, the previous years working on other projects, I didn't have much exposure to thermal engineering, working on other projects, electrical engineering, avionics exposure, structural engineering, and so electrical engineering, avionics, that progression really gave me an appreciation. And so being able to see that progression really gave me an appreciation.
And joining us now is the Chief Engineer, Amanda Cutright. Amanda, how you doing? And joining us now is the Chief Engineer, Amanda Cutright. Amanda, how you doing?
I'm doing great. Today's a great day to launch a balloon.
September 10th was the first date we had a chance to launch it, and now we're here. A long time since September 10th was the first date we had a chance to launch it, and now we're here.
It looks like a launch day. It looks like a launch day. It is. It's going to go today. I can feel it. It feels like